Algebra 2 trigonometry regions, absolute value equations. What is the solution set of the equation absolute value of 3 minus 2x equals 5? So the way we solve an absolute value equation is we take what is in between our absolute value bars, and that's what I'm calling these two vertical bars. These are called the absolute value bars. And so we take whatever's in there, the expression or whatever there, 3 minus 2x, and then we also set it equal to whatever we have over here, 5. So we start off by pretty much just removing the absolute value bars. But we don't just do that. We also put an equal sign on the left side of the equation and set it equal on the left side to the negation of this, to the negation of 5, which would be negative 5. And so again, just the setup is really the key to this whole thing is you just remove these bars and set it equal to what you have over here. And then on the left side, you also have it equal to the negation of whatever is over here. And if there's an expression over here, you negate the entire expression. So whatever's over here, you negate it, and you set it equal on the left side. And so now we actually have two equations here kind of put together, and we're going to solve them simultaneously. Meaning to get x alone in the middle, I need to subtract 3, and I'm going to do that to my equation over here on the left and also my equation over here on the right. So I subtract 3 to every part, and that's going to result in negative 8 equals negative 2x equals positive 2. And then what would I do to get x alone? I would divide by negative 2, and again, I do that on each part. So divide by negative 2. Negative 8 divided by negative 2 is positive 4. And it is also negative 1. And so I end up with two solutions, which you can then split up to say x equals negative 1 and 4. And that's why our answer here is A. Now, these are very simple to check, too. Now that I know that x is negative 1, I could come up here and think, all right, well, if x is negative 1, what does this come out to be? Well, this would be negative 2 times negative 1, which would be positive 2. 3 plus 2 is 5, and the absolute value of 5 is 5. So that's pretty straightforward. Well, what about when x is 4? If x is 4, this would be 3 and negative 2 times 4, so this would come out to be negative 8, and so you'd end up with the absolute value of 3 minus 8 equals 5, and 3 minus 8 is negative 5 equals 5, and this is a true statement. The absolute value of negative 5 is positive 5. So I know you guys all learned absolute value a while ago, but just in case you don't really remember, what it really is asking is how far is this number from 0? And negative numbers have a positive distance away from 0 on the number line. So negative 5 is 5 away from 0. So the absolute value of negative 5 is positive 5. But notice that when we set up our two equations, we left this expression exactly as it was. Some people think, you know, whatever's in here, I got to make positive because that's what absolute value is. That's not really the case. You leave it whatever it is and solve. When you come down to doing the absolute value of a single number, that's when negatives become positive because it's a reference of distance to that number line 0. Let's try another one. What is the solution set for the absolute value of 3x plus 2 equals 5? So again, this one happens to be 5 again, but I'm going to set it equal to 5 and also to negative 5. So I'm going to end up with negative 5 equals 3x plus 2 equals positive 5. And subtracting 2 on both sides, I'll get negative 7 equals 3x equals 3. And dividing 3 on both sides, I get negative 7 over 3 equals x. And that also equals 1. Now, you really do want to check these, though, because who knows, maybe one of these won't work. And that tends to happen in Algebra 2 a lot of times, so you really need to kind of be careful. Tomorrow's lecture is going to be on inequalities with absolute values. So this is going to change to something like less than or equal. And that's where you really have to be very careful and check your answers. But we should check them here too. So 3 times negative 7 over 3 plus 2 in the absolute value bars here. And so 3 times negative 7 over 3, our 3's would cancel out. We'd end up with negative 7 plus 2, which is negative 5, and the absolute value of negative 5 is 5, so it works. If you plug in a 1, that's a little simpler here. 3 times 1 is 3, plus 2 is 5, and so that works also. So both answers are correct. This next one, the key difference here is notice that in these first two examples, the only thing on the left side was what was between the absolute value bars. The only thing over here is what's between the bars. But in this equation, we have the absolute value of 2x minus 1, but then we also have this plus 4. And so when that happens, you have to first isolate the absolute value bars before you go to what we've been doing over here with the equal sign on both sides. So I'm not going to set it equal to 8 and negative 8. I first have to get rid of this plus 4 before I do anything. So I need to rewrite this equation as the absolute value of 2x minus 1 equals 4. And that came from the fact that to move this 4, I minus 4 on both sides. Now the absolute value is the only thing on the left side. And so now I can go to setting up my equation of negative 4 equals 2x minus 1 equals positive 4. So the 4 and its negation over here. And so now solving this, I could add 1 to both sides. Let's see, that's negative 3 equals 2x equals 5. And then dividing everything by 2. Negative 3 over 2 is x, and so is 5 over 2. And so let's see if we plug negative 3 over 2 in here. And that would be, so let me just write that there, negative 3 over 2. The 2's would cross out. I'd end up with negative 3 minus 1 is negative 4, but the absolute value of negative 4 is positive 4, plus 8, plus 4 is 8, so that one works fine. And how about if we had 5 over 2? Again, the 2's would cross out, and it'd be 5 minus 1 is 4, and the absolute value of 4 plus 4 is 8, so they both work. Again, I'm sure there's probably supposed to be a comma here. And so the answer, again, here is B. Now, this next example is one where the absolute value is isolated on the left side. There's nothing over there. It's not between the bars. But our right side is an expression. And so we have to negate the entire expression. And I mentioned that earlier. You negate whatever's over there. So you are going to have 3x minus 1 equals x plus 5. But on the left side, the negation of x plus 5 is the negation of the entire term. So that would be negative x minus 5. I have to negate everything that's over here. And so solving this equation, let's see. We can add 1 everywhere, and so that's going to be negative x minus 4 equals 3x equals x plus 6. And you know, it's getting a little complicated in here because I'm going to have these x's, but I can minus x everywhere. Let's try that. And if I minus x, I'll end up with negative 2x minus 4 equals 2x equals 6. And so why did I minus x everywhere? Because I wanted to remove this x here. So if I minus that x, it would cross out. But I kind of need to do it everywhere if I'm going to keep it balanced. And so now I can solve this by dividing everything by 2. And so if I divide everything by 2, let's see what our result is going to be. And you have to, when you divide everything. So I'm dividing everything by 2. I'm going to end up with negative x minus 2 equals x equals 3. And so I end up with x equals 3 over here, and that's going to be one of my answers, but I'm not quite done with this side. And so on this side, I would need to add x everywhere to get rid of this, and I'd end up with negative 2 equals 2x when I add x over here. And then I can divide by that, and I'll also get a negative 1. Now, yeah, I could have added x everywhere, but once I was done with this side, it didn't really matter. I mean, I would change it then, but once I know that answer, I'm good to go. You know, another option for when it gets complicated instead of doing this all in one piece is to separate it. I mean, I do feel it's really not that difficult when you're just dealing with numbers on both sides, but when you're dealing with expressions on both sides, another option would have been to completely split it up and just solve this equation as 3x minus 1 equals x plus 5, and then separately solve this equation. Negative x minus 5 equals 3x minus 1. So you don't have to do them all in a row, but it is an option. And so finally, the last thing we got to do is check our answers. Plug in a negative 1 here, but also here. And so 3 times negative 1 is negative 3, minus 1 would give us negative 4. The absolute value of negative 4 is 4. Negative 1 plus 5 is 4, so that one checks out. How about a 3? That'd be, if we plug in a 3 here, 3 times 3, 9, minus 1 is 8. And if we plug in a 3, 3 plus 5 is 8, so that one also works. So negative 1 and positive 3 are the answers to that. Okay, guys, so we'll do a bunch of these in class tomorrow, and we'll continue this worksheet. And the next video will be on solving absolute values, but with inequality symbols attached. Take care.